Okay, guys, so our learning target today is I can find the arc length and the area of a sector and a segment. So there's a lot of stuff here, a segment, and let's say of a circle. So we got a lot to learn today. Okay, so good things. The good thing today was it's Friday. That was our good thing. All right, and remember, guys, your circle, the little cutty pasty circle thing we did, that is due on Monday. So have that. And if you're not here, we'll kind of show you what to do when you get here. All right. So here's what I need to do first. A lot of writing today. I want you guys to draw this circle out, and we're gonna just kind of talk about some things about circles. So the first thing I want you to do is I need to find my learning pen here. Okay, there it is. All right. The first thing I want you to do is I want you to write down this writing right here. Okay, this writing right here. And then we'll talk about it. And then after you get done with that, draw out this circle. And we're just going to talk about the parts of a circle. We know some of this, but get it down first. And then you can, I'll speak about it here in a second. So I'll give you a minute or two to copy these down. And then you can, we'll talk about it. All right, go ahead and do that.
Is that a zero or a theta?
That is a theta.
What on the outside?
That is a theta on the outside also. Isn't that interesting? It's why would theta be on the outside and the inside? That is interesting, isn't it? Very interesting. Why would there be a theta on the inside and an outside? That is just mind numbing. The Greeks. And theta was around before zero was around. Much earlier than zero. Okay.
So that means a zero. All the thetas look like zero. I mean,
They kind of look like Easter eggs. I agree. Yep.
What? Where did you get Easter eggs?
Okay. So while you're writing this down, let me just kind of talk a little bit. Okay. So first of all, when we're talking about an arc, we're talking about the part of the circle that is contained between 2 points on the circle. Now, if you notice, the yellow part, you could think of it two different ways. Well, if I said, what is the arc AB? Well, you could be looking at the smaller part, the yellow part, or you could be looking at the purple part. So we like to give names. The yellow part is called the minor arc. You guys understand that? And the purple part is called the major arc. Now, this is an important part. In this class, we always assume minor unless we are told otherwise. Do you guys understand that? So when I say find the arc length of AB, I'm always speaking about the minor arc. Now, sometimes math books will put another point on there to make it, like if you put another point in between A and B, you could say find ADB or something like that. But I always just say minor arc or major arc. Okay. Questions, Chris?
What if the distance is equal?
Ooh, well, that's interesting, isn't it? When would that happen? All right, well, that's a good question, Chris, and we will come across that. So you have this. Chris has I think it's Chris usually is the one that kind of has a ability to read the future, so he has good superpower in that. Okay, now here's another thing, and I think one of you, I think it was Wyatt, noticed that we have theta here and theta here. Okay, so we'll talk about that. We will talk about that. Okay, now I'm going to just kind of move it down. Now, notice, guys. Okay, and let me get rid of my picture here. An angle formed by two radii is called the central angle. So theta, in this case, guys, is a central angle. So theta is a central angle. Okay, it's very important you understand what a central angle is. It's an angle formed by two radii. Okay? Bless you. Okay. Now, just moving down a little bit here. Okay, now I just want to say this and then I'll come back to it. The measure of the arc is always equal to the central angle. You guys understand that? So, if you want to know, when we measure an arc, we measure it in degrees. Okay, now I didn't say arc length, I said the measure of the arc. You guys understand that? Or we measure it in radians also. So this yellow part, if we're going to give a measure to it, it's going to be the same measure as theta, as the central angle. These two angles are always the same. Okay, these two measures are always the same. That's a good point. These two measures are the same. So if theta is 90 degrees, then if the central angle is 90 degrees, then the measure of the arc is also 90 degrees. Now, we're not taking arc length. We're not measuring its length. It's just a measure. We're measuring a circle in degrees. Okay, guys understand that? Or radians. But these two things are the same. So if this is 83 degrees, if we're measuring in radians, in degrees, then this has to be 83 degrees. Y'all see that? If this is pi over 4 in radians, then this is pi over 4 in radians. You guys see that? Okay. Now, if we want to figure out the major arc, then we have to take 360 degrees and subtract theta, right? Or we can say 2 pi minus theta. If we're doing, this is degrees, and this is radians. You guys understand that? So if we ever want to find the major arc, okay, the major arc can sometimes be a major pain because we have to take the remain. So this is another degree right here outside the major arc, and so its central angle is going to be here. You guys understand that? This is the central angle of the major arc. And notice it's an angle bigger than 180, which is kind of weird, right? You guys see that? In trigonometry, we can have angles that are bigger than 180. Okay? You guys see that? Okay. Now, arc length. Now we're talking arc length. Arc length is the linear distance of the arc. Now we're talking about arc length. Arc length is the linear distance of the arc. Hi, Sam. Come on in. Okay. I'm taping this, Sam, so you can catch up later. All right. What does that mean? It means if I go up to the arc and I look at this minor arc like here, and I take AB, so this is the arc AB, right? And I lay it out flat in a line. Okay? This is the arc length of AB. Arc length. So what I do to find arc length, I don't actually lay it out in a straight line, but that's what you're actually finding. Arc length is you take this AB and you lay it out flat and you figure out how long of a line it would be. You guys understand that? Okay, so the arc we measure in degrees or radians. Okay? Yeah, Chris?
So,
Arc length we just measure in linear units. Sorry, Chris.
Is like the same as theta, right?
What?
Like the angle on the inside, the central angle, is
Yep.
the same as
Theta. Yep.
in arc length.
Yep.
Couldn't you do like theta minus circumference?
You could use theta minus circumference. Yep. Remember, circumference of a circle is 360 degrees, right?
Yeah. Oh, yeah.
Okay. Or 2 pi. Okay. Does everyone understand that this degrees or radians is the measure here? When we lay it out flat, these are linear units like centimeters, feet. All those are all linear unit, right? You guys understand that? Questions? Good question, Chris. Anybody else? Okay. Now, here's an interesting thing here. Okay, we have two formulas for arc length. Okay, so we have an arc length formula in radians, and an arc length formula in degrees. Now, don't worry about drawing all this stuff. Don't worry about all this. Let me just show you. Just worry, and I should have blocked this out earlier. Okay, just worry about. Don't worry about all that. Just worry about that.
The highlighted yellow part.
Yeah. Now, remember how Mr. Roden says he likes. Oh yeah, this is not R length. I tried this text to shape, ink to text thing, and it sometimes doesn't read my writing right. That's arc length. Okay, so look, guys, look at the beauty of radians. Arc length is just theta times radius. Do you guys see that? Isn't that nice? Now, arc length in degrees is much more complicated. You got to take 2 pi r and then multiply that by the fraction of theta over 360. So there's a vote for me in my book for radians. Radian is a much cleaner formula. Now, why is radian so much cleaner? Because in the definition of a radian, this over this is a radian. 2 pi over 360, that's a radian, right? So the nice thing about radians is your formulas are much cleaner, okay? We're used to degrees, but there's a lot more things involved with degrees than in radians. So you actually sometimes like having measures starting at given measures in radians. If we have degrees, we have to do a little more work. You guys understand that? But we need to be able to juke and jive between these two. So you want to have both formulas down. As you move on in mathematics, radian, especially for arc length and when we get to area, are much more preferred because you can see the formula is much cleaner. Okay? So that's why the radian is a much cleaner formula. Hey, what's up? Yeah. Absolutely. Yeah. Yep.
You're in trouble.
No, I bet he's helping you with something.
He is my most favorite colleague.
Wow.
All right.
Wow.
Okay. So let's do an example. Let's call this example number 1. I want you to draw this out. We're going to find the length of the minor and major arcs. So which one of these formulas are we going to use? Are we going to use theta r, or are we going to use 2 pi r theta over 360? Yeah, we got to use the degree one because I gave you the measure in degrees. You guys see that? Because this measure right here is in degrees, we have to use the degree formula. You guys understand that? Okay. So you should prefer, when we're doing arc length, you should prefer radians because it's much cleaner. All right. Now, let's go ahead and do this formula really quick, and we're going to find the arc length of the minor arc. You always want to find your minor arc first, okay? You always want to take your minor arc first, okay? So when you find the minor arc, we're going to say 2 pi r, but r in this case is 9, times theta, which is 166 degrees, over 360. You guys understand that? Okay, so calculator time. First of all, what I would do is, well, this is going to be 18 pi. I might do this. I like to put my numbers first. Sorry. So this is going to be, bless you, this is going to be 18 times 166 over 360 times pi. You guys see that? Okay, so help me out. Let's crunch these a little bit. What is 18 times 166 over 360? So take 166, divide it by 360, and multiply it by 18. You're going to get a decimal. Someone tell me what you get. What did you get? So this is about 8.3 pi. You guys see that? Now, if we want to round to the nearest tenths place, What is 8.3 pi to the nearest tenths place, Xavier?
2.6.
Much bigger than 2.6. 26.1. Okay, and it's centimeters. It's a linear. So we're here, it's centimeters. It's a linear measurement. You guys understand that? Now, how would we, that's the minor arc. How would we find the major arc? Now, Chris came up with a really good solution. You find the circumference and subtract off the minor arc. You guys see that? So to find the major arc, again, it's a little bit of a major pain, right? To find the major arc, what we need to do is we need to find the total circumference of this circle. Well, how do you find the circumference of a circle? 2 pi r. So it's going to be 2 pi r minus, in this case, 26.1. Okay, see that? So this is going to be 2 times 9. So basically, this is going to be 18 pi, right? So this is going to be 18 pi minus 26.1. Obviously, it's going to be longer than 26.1. What is it, guys? Xavier, do you have that number? 30.4? So the minor arc length is 26.1, and the major arc length is approximately 30.4 centimeters. Guys got that? Okay. So major arc length, minor arc length. But no, we're never going to say minor arc length. If we're finding arc length, we're always going to assume minor arc length and let's hold major. Do you guys understand that? So it's kind of a math thing. It's like we don't put 1 in front of x. We just say x, right? We don't say minor arc. We only say major arc because if we don't say it, it's always minor. You guys understand that? In this class, at least. All right. Now, your job, let's try example number 2. But now life is good, right, class? Because we are in what? Radians. Okay? So now let's find the minor arc. Even though I said we need to find minor arc length. Okay? And then we'll find the major arc length. Okay. Now, what is the formula for arc length in radians, guys? Arc length equals what? Okay, so I'm going to say L for length equals theta. What's theta, guys? 3 pi over 4, right? Times your what? 12. Now notice, how do you normally, guys, radians oftentimes, unless they've already been converted to decimals, have pi in them. Okay, that's a very, 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 it's a giveaway. If you have pi in a degree, you're probably dealing with an exact value in radians. You guys understand that? Now, I could have given you this as a decimal, but I would have to write the word radians next to it. You guys understand that? But if it has pi in it, it's a radian measure, okay? So now, here's the deal. Don't just start crunching. Look, the great things about radians oftentimes is things cancel out. So if I have 3 pi over 4, and I want to multiply that by 12, because remember, guys, it's just length, arc length is equal to theta times r, right? So in this case, this becomes a 1, and this becomes a 3, right? So this is just going to be 9 pi. You guys see that? And what is 9 pi as a decimal? 30-something? What is it? In the low 29, 28. Okay, so it's going to be 28 point what? 3 centimeters. Right? You guys see that?
Yeah.
Why is it the same equation for the minor one?
What?
That's, oh, by the way, this is the minor arc. Sorry.
Yeah, you wrote it as major.
This is minor, sorry. We found the minor. My bad. Because I wrote it where okay. Now, this is the minor arc. Sorry, guys. My bad. Thank you. Okay. Now, this is the minor arc length. Now, to find the major arc length, okay, we got to find the circumference of the entire circle, right? You guys understand what I'm talking about here? To find the major arc length, we got to find the circumference of the entire circle. Well, and then we're going to subtract off 28.3. Well, in radians, what is circumference in radians? 2 pi r. Very good. So we're going to take 2 pi r, because in radians, that's just the circumference of a circle, right? Minus 28.3. Well, 2 pi r is going to be 2 times pi times 12, right? So this is going to equal 24 pi. You guys agree with 24 pi? And we're going to take 24 pi minus 28.3. So this is going to be the major arc, not major arc. Sorry for the handwriting here. That just looks terrible. I just need to change that. That's the major arc, right? And what is 24 pi minus 28.3, guys? What is it? Okay, this is going to be approximately 47.1 centimeters. Did I do that right? Did I write? Is that what you guys got? Okay. All right. Question about minor and major arcs in radians. Now here's a fun Z problem. Okay. Find the arc length of AB.
21.
It doesn't matter. The answer is going to be in centimeters. You can use radians or you can use degrees. Why did I not say find the major arc with the minor arc? It's what's the word that describes what we're finding here?
Split in half.
Right. Oh, and by the way, yeah, so I just want AB. So this is when the major equals the minor, you have a semicircle. That's what Chris was talking about over here. Okay, Chris was mumbling to me about half of a circle, right? This is what?
Can we mark the angle as 180?
Sure. Well, let's do this. For fun, we could mark this side. If we want to do degrees, this is 180. But if you're a radian person, what would this be right here? Pi, right?
Oh, pi, bet.
See that?
Easy, bro.
So sure. This is a fun problem where you could put 1 degree on one side and radians on the other. And choose. Are you a degree person or a radian person?
Who is a degrees person? Like the nerds who like the extra word.
Okay. Now, notice in math, here's a really good important point. If you're given a diameter, you're never going to be given the angle. You have to know it's there. Does everyone understand that? Okay.
What? I mean, diameter of the entire circle and radius is scale.
Okay, so who can raise their hand and tell me how they did this problem? So we want to find arc length AB. Okay, so we want to find the arc length of AB. How would I do this problem, Tanner? Yeah. 26 is all the way across. It is a diameter.
Same thing.
So if I put this in words, find the arc length of a circle with a diameter of 26 centimeters. Okay, not 100. This is what it would be in a sentence. Find the arc length of a circle with a diameter of 26 centimeters. That's what I'm finding here. You guys understand that? This 180 and this pi are not part of the diameter. Those are the assumed central angle measures. You guys understand that? Does anyone have don't just tell me your answer, but tell me how you found your answer here. I'm going to go with Austin on this one. So, Austin, I want to find the arc length. So, what am I going to do? Arc length equals what? Are you a radian guy or a degree?
I'm a radian.
Okay, so what's the formula we're going to use?
So pi
Pi
times the radius,
which is 13. So this, do we all agree that this arc length is really just 13 pi?
Yeah.
And what is 13 pi approximately, Austin?
40.8.
Approximately 40.8 centimeters. Okay. All right. Does everyone understand arc length? Now let's move on to sectors. All right. Draw that down. Now, ladies and gentlemen, the sector of a circle is the area part of a circle that is contained between the arc and the two radii. Okay? We, on our little kindergarten project, when we started cutting the circle up, what we really did is cut the circle up into 18 congruent sectors, right? That's what we were doing. So you can think of sectors as what we did when we cut them all up. You guys understand that? So if you want to find the area of one sector, a sector is like the piece of pie, right? So a sector is the area part of a circle that is contained between the arc and the two radii. So arc AB and the two radii contain the sector. Now we're talking sector of a circle, right?
Yeah.
So there could be a sector of other types of things. I don't know. I'm not that smart to know if there's other sectors in math. But when we're talking about a sector of a circle, we're talking about the piece parts there. Now, we need a formula. What two kinds of formulas do you think we're going to have for a sector? We're going to have one in what kind of units and one in another kind of units. We're going to have a radians and degrees. Which one do you think is going to be the more simplified formula? Radians is going to be a simplified version, but here they are. So here they are. So area of a sector, if you're going to do it in degrees, is theta over 360 times pi r squared. Okay. Area of a sector in radians is 1/2 r squared theta. Now, don't worry about this area of a segment thing. We'll get to that. So let me just mark that out because we'll talk about areas of segments in a minute. So don't worry about segments. Just worry about sectors. Okay? So obviously, when we take our circle test sometime late April, early May, okay, we will probably want all of these formulas unless you're a memorizer on a note card, right? So I don't know when our circle test is going to be. It's way too early to tell. I'm thinking probably late April, early May, right? Sound good? No, we'll do a circle test, and then we need our 3D test. Surface area and volume test is what it is. I call it the 3D test. Okay. The 3D test, and then you guys have your Doherty algebra test. So.
Oh, that's. Wait,
So-
what? What test?
So Doherty usually sends over algebra tests to make sure you guys are up to. We will review for them. Just it's simple algebra stuff like factoring, quadratic formula, linear equations. Okay. So what we want to do now is we want to find the area of this sector. So the formula, since, ladies and gentlemen, this sector is in degrees, I'm going to need the formula area equals theta over 360 times pi r squared, right? Okay, so now area is equal to theta, which is 92 degrees, over 360 times, I'm going to move radius over, 13 squared is 169 times pi. See that? And then now it's just a calculator issue here. Someone do me a favor and multiply all and divide all that out for me and tell me what you get.
135.7.
Chris is saying 135.7 pi, right, Chris?
Yeah.
So I need someone
No,
to
not pi. That's
Did you multiply pi in?
all of it, yes.
I don't want pi in
That
there.
is 43.2, I think.
So someone tell me what is without the pi being multiplied in.
It's 43.2 pi.
Chris is saying 40 what?
3.2.
Chris is saying 43.2 pi. Do you guys agree with that? Approximately? Okay, so I'm hearing agreement on the 43.2. Notice, guys, we always want to leave pi out into the very end. Okay, so it's 43.2 pi, and then we'll multiply it at the very end for an estimate. And what is that going to be, guys? What is it, Xavier? What do you got? 135.67 centimeters. Now we're talking about an area, so it's a square unit. It's not linear units now. Do you guys see that? Square units. Okay. You guys ready? I want you guys to do this example on your own. I gave you a degree measure. You can probably assume already you're going to use but I put a twist on it. You actually have to find the area of the major arc sector. So that's interesting. Wow. I'm going to make you chew on this a little bit. Okay? There's a lot of different ways you can do it. I know how I would do it.
Why don't spoil it?
You can do it that way. Yep.
30 centimeters plus 5 pi.
Dude, it's easier now.
200.
Oh, I have to talk to Mr.
That'd be a decimal.
909.
The radius squared is
Smash
times.
Yeah. Do you know that we're playing all start by smash?
You guys okay with this? Are you typing it up?
Yeah.
Sam, I don't think you should.
How do you type this up, Sam? I'm very curious how you would type this up.
There's a drawing thing.
Oh, there is?
And you can like shape on it.
Oh,
but
that's
it
cool.
takes a while.
That's cool.
Trust
Okay.
me.
Okay. I'll give you my opinion. Now, I think it's Chris, Wyatt, are kind of mumbling over here about find the area of the entire thing and then subtracting out the minor arc sector. You can do it that way. Here's what I would do is I would go right and try to figure out this central angle right here. Well, I know there's 2 pi r or 2 pi radians, right? For a full circle. So what I would do is I'd take 2 pi and I'd subtract off the 5 pi over 6. Now you're going to have to get a common denominator, that's no big deal. You're just going to have to multiply top and bottom of this by 6, right? See that? So this is 12 pi over 6 minus 5 pi over 6. You guys see that? I've just got a common denominator with the 2 pi because this is really a 1. And then 12 pi, what's 12 minus 5? So this is really 7 pi over 6 for the major. Did you guys see that? And then that's what I would do. You could just use this and then subtract it off from the entire thing. But I like to just get to my radians that I have and go from there. Do you guys understand that? Any questions? Okay. Now, if I do it my way, then my area of the sector is just going to be 1/2. What is it? 1/2 r squared theta, right, guys? See that? And then I'm just plugging numbers in here. Well, I have 1/2 r squared, which is 30 squared, times theta, which is the 7 pi over 6. See that? Bye, Nicole. It is the same answer, Chris. Yep. But I'm just showing you how I would do it. Now, 30 squared is, I believe, 900, right? So this is 1/2 times 900 times 7 pi over 6. Well, half of 900 is what? 450, right? So this is 450 times 7 pi over 6. Well, I don't know. What's 7? Then you just what? So let's just go right to the answer. What do you guys get for a decimal? The whole thing after multiplying by pi. What do you get, Chris? 1,649.3. And that, what kind of units are we talking about here, class? Centimeter squared. Okay. So we've done a lot today, but I want to do a lot today. So the last thing I want to talk about, and obviously there's no homework on this yet. I'm not going to throw delta math at you yet. I want to talk about the area of a segment of a circle. Okay, now I want to get rid of the formula really quick, and I just want you to see what a segment of a circle is. Okay, the segment of a circle is the area of the shaded region right here. You guys understand that? See the shaded region right here?
Are you just making? Okay, never mind.
So I want you to draw this out. This is a segment of a circle. Okay. How do you find the segment of a circle? Well, it's basically the area between, so the way to say it is this on a circle is called a chord. So if this is AB, okay, so this is an area. So a chord on a circle is a segment, a straight segment that goes through the circle and connects two endpoints. You guys understand that? So there's two different things. We have chord AB and we have arc AB. You guys see that? So a way to say it is this. A segment, in words, in geometry words, a segment is the area contained between a chord and an arc of a circle. Now, I will say this: the chord and the arc have the same endpoints. You guys understand that? I probably should put that in. Where the chord and the arc have the same endpoints. So we're talking about a segment, and this is where we'll go next week in between testing and stuff, is we're going to start to look at, hey, how do we find the area of this thing right here, okay? Because it's the area that's trapped between the arc and the chord. And so that's where we're going to go next week with this. I don't think there's not enough time, and I got further than I really wanted to, actually. So you guys did a really nice job today. So remember, before I stop recording, get that picture, that pi r squared model, that little Cuddy model to me. If you're not here today, just maybe talk to a friend, or I can explain it more on Monday, and then we'll see you later. Have a good day, guys. Bye.